Hi, good morning and good afternoon, everyone. Thanks for joining us today for this new webinar by the Cyber9's team. My name is Jean-Jérôme, and I'll be looking after you for the next hour or so. If you have any questions on the GoToWebinar system or need assistance with the audio and so on, feel free to let me know in the question section of your control panel or in the chat section as well. And I'll do my best to help you out. You can ask questions in general at any moment during the next 60 or so minutes. About the content as well, of course, so feel free to use the question section for that as well. And you can also contact me directly after the webinar at jj@cyber9s.com if you'd like to continue the discussion there. Just before we get started, a few words on ourselves and Cluster Control, our product. So Cyber9s, we specialize in automation and management of open source databases. And here we focus on these four main areas of the database management lifecycle, which is the deployment and monitoring, first of all. And then you also have management, of course, and scaling. The deployment and monitoring you can find as a free tool and service via our product Cluster Control. So you've got provisioning and monitoring features there in the product. And we also have management features, of course, around database upgrades, scheduling your backups, doing cloning, configuration management, as you can see here, and scaling as well as part of those feature sets of Cluster Control. We support SQL and NoSQL open source databases, so all of the different MySQL flavors, the different MongoDB flavors, and then Postgres SQL as well. We have a number of customers and users, of course. Over 8,000 users use Cluster Control to deploy, monitor, and in part also manage and scale their database clusters. And you can see some of our customers here. They range from telecommunications to entertainment to publishing and so on. Government offices as well. They all use Cluster Control. You can get started with Cluster Control for free. There's a community version of the product, and there's also a commercial license if you wish then to continue using management and scaling features, which are part of the commercial offering. But for today, I'm joined by my colleague Christoph, who's going to talk about MySQL Query Tuning. You probably have seen the communication so far. We've done, this was a trilogy, so 3 parts to this webinar session. This is the last part on hinting the optimizer and SQL tuning or improving query performance. So Christoph will be covering that for the next 60 minutes or so. These webinars take a little bit longer than usual ones, so we usually go over the hour. So I hope you made some time available for that. The presentation itself will take 60 minutes, and then we'll have time, of course, afterwards for your questions, and we can have a discussion at the end of the webinar. But to get things started, and before I hand over to Christoph, I'd like to ask all of you in the audience a quick question. And this is all around, what MySQL versions you're currently using yourselves, just to see who we have in the audience today, and see how the content also, of course, fits, with the MySQL versions that you use. So whether it's 5.7 or earlier versions for MySQL Percona server, or maybe you're also using MariaDB. So it'd be interesting to see if we have any MariaDB users today. I give this a few seconds so you can all participate and provide your feedback here. And I'll share the results, of course, once everyone participated. The session is being recorded as well, so you'll be able to watch the session again, and the next couple of days we'll make that available online. But for now we're live, and I'll just close this poll now and share the results. Right, so this is a multiple answer question, but it looks like the vast majority of you are using MySQL/Percona server version 5.6 and then 5.7. So it's nice to see quite a lot of you on the newer versions already. And a big share also on MariaDB 10.1, which is nice to see. And so this is it's a nice mix. Christoph, any comments on this before you take over?
Yeah, definitely. So yes, I agree that this is really nice that we see, a lot of like newer versions of the MySQL, because when it comes to the optimizer, when it comes to the how MySQL tackle queries, um, things have changed and things are changing with like every new release. So MySQL is getting better with it. So for those of you who are still running 5.5 in production, I think you may see some examples why it would be a nice idea just to to upgrade to one of the newer MySQL versions. So yeah, but again, as you said, majority is using pretty recent versions, so that's really nice to see.
Great. Yeah, so thanks everyone for your participation here. And with that, I'll hand over to you, Christoph.
Okay, thank you, JJ. So good morning and good afternoon, everyone. My name is Krzysztof Książek, and as JJ said, we'll be talking about optimizer and query performance. So this is the third and the final installment of our webinar, which is focusing on the MySQL query tuning. So if you haven't watched previous parts, feel free to check our webinar replay pages, and you can find them there. But today we are going to talk about a couple of things. So we will start with some basics. We will start with InnoDB index statistics and cost model that is in MySQL, so we can better understand how optimizer picks queries and picks the query execution plans. Then I will be talking about hints. So how to like bend the optimizer to your will if you find that the query plan is not really the most optimal one. And finally, I will be going through some of the I would say anti-patterns that I found from my experience that I found pretty common. So we will go through them and see how we can work around them or how we can avoid them. So yes, so the index statistics, we will start with that. And basically in the query execution plan, the optimizer to create a query execution plan has to base on some sort of data. And so we are talking about data cardinality, we are talking about data distribution, and all this data is basically stored, is calculated as index statistics. We will be focusing on InnoDB because InnoDB is the way to go at this point. Well, since like since like a while, but yeah, we will be focusing most on InnoDB here. So those statistics up to 5.6. So the default behavior was that the statistics were recalculated pretty often. So they were recalculated when analyze table has been explicitly executed. This is actually obvious because analyze table is intended to recalculate index statistics. But also when we run queries like show table status, show tables, even use schema, show index. So then the statistics were recalculated. They were also recalculated when either 1/16 of the rows in the table or 2 billion rows were modified in the table. So I mean the main problem was those queries which are show table status, show tables, which tends to be executed pretty often by for example, some connectors maybe. Some applications, and this was constantly recalculating statistics. And to calculate statistics, InnoDB performed a lookup on 8 pages per index. So, so let's wait here. Like, let's stop a moment. So we're talking about 8 pages. Yes, 8 pages, 60 kilobytes each. So we are talking about 128 kilobytes of data. and the index can be large. So as you can see, we are talking really about some small subset, very small sample of the data, and we had to, and the optimizer had to base on this very small sample. There was possible, I mean, it is possible to change the number of pages that the lookup is being, that are checked in the table. Right now, the variable for that is InnoDB stats transient sample pages. Before, in the previous versions, it was InnoDB stats sample pages, from what I remember, which is now deprecated in 5.7. But you have to keep in mind that more data you're going to read to check while you're calculating statistics, the longer the process will take. And if it happens often, this can become some sort of like additional burden, additional load on the system. And obviously, as you can imagine, after the query, after the statistics were calculated, the query execution plan could change, and that basically resulted in plans changing one way or another, very unstable. I mean, usually it worked good, but if you run into a case where you had this flipping plan between like two options, it was really annoying. In 5.6, by default, statistics became persistent, like more persistent. So they are not recalculated for every command like show table status, and the other similar commands. They are recalculated only when there is explicit analyze table, or more than 10% of the rows in table were modified. So as a result, we have more stable execution plans, and as a result, the recalculation happens less often, which means that we can accept some longer, some more I/O per index statistic recalculation. So right now the sample is larger; it's 20 index pages. Again, it's not much; it's like 320 kilobytes, but well, it's like two and a half times more than it used to be in 5.5. You can also change it through InnoDB stat persistent sample pages variable. And if for some reason you feel like using the previous behavior, you can disable the persistent. You can switch between persistent and not persistent statistics using InnoDB stat persistent variable. So you can just enable or disable this variable here. So we have some data about the data. I mean, about how data is distributed in a table. But then that's the one thing. Then we have to we can build a couple of different query execution plans, but then optimizer has to have some sort of way to basically to determine which of those query execution plans is the most efficient one. So here comes the cost model, and we will be talking about it for a couple of slides here. So basically, as I said, to determine which query execution plan is the most efficient, MySQL has to assess cost of those different possible query execution plans. And obviously, the one is the least expensive will be picked to execute. So basically, how it works is that every operation, like reading data from memory, reading data from disk, creating temporary table, or in memory or on disk, and operating, like adding rows there or restoring rows from that table, like evaluating row conditions, comparing rows. Every single operation has its own cost assigned, and some fixed value, yes. And then based on how those operations are performed to execute the query, how many of them, what type of operations, the cost is calculated. Historically, those numbers were hard-coded, so it was just, you couldn't modify them at all. It changed with MySQL 5.7, where new tables were added in MySQL schema, table server cost and engine cost, which allow you to manipulate those costs for different type of operations. So on the right-hand side, you can see the contents of the server cost table in MySQL 5.7 just after the installation. So we have different costs here, and then the cost value is null. If the cost value is null, then the default one is being used. But you can update here, and you can update those columns, and you can set whatever you like. So, for example, disk temp table create cost, disk temp table raw costs are the cost to create and maintain some operations on disk temporary table. And by default, the cost to create is 40, and to manipulate rows is 1. And actually, this is, that's not some sort of unit, it's just arbitrary number, which you then can compare between different costs. So it's not like anything real, but just a number to compare. Then we have the same type of operations for in-memory temporary table. So the cost to create is like by default is set to 2. Cost to operate on is 0.2. The cost to compare record keys, so that the less file likely. The more expensive the cost is, the less likely file sort will be used. By default, 0.1. The cost to evaluate rows is set to 0.2. So, and as I said, you can put here your own values if you like. The second table, engine cost, is slightly different. So first of all, we have this engine name column, which can be set to. So basically, we can define different costs for those operations per different engines. So right now we have, by default, it's just default, so every single engine is included, is affected. But you can set, for example, different costs for MyISM and different costs for the InnoDB. A very interesting column, not used right now, but very interesting column indeed, is the device type. So it is designed here so that in the future, it is said that it will be possible to set different costs for different types of I/O devices. Frankly, I'm not really sure how this will be done, because it implies that MySQL will be able to identify that this particular volume is like is Spindle and this one is PCI Express SSD. I don't know how they plan to do that. Maybe based on the mount points. I don't know. But if it will be able to, if it will work, that would be a really nice addition. So we could just set different costs based on where the data is located, which obviously makes really sense. And then we have cost name. We have these different costs. So we have I/O block read costs. So cost of reading a page of data or index page from disk, by default is set to 1. And cost of reading index of or data page from memory, by default is also set to 1. And again, the cost value is something you can just update here and set to whatever you like. So right now, MySQL Optimizer is undergoing refactoring and rewriting, and Oracle is focusing on it pretty heavily. So the new features will definitely follow in the next releases. So, but even now, like with this addition to MySQL 5.7, it is really great because you can modify those costs, you can tweak them depending on what type of hardware you're using. Yes, because obviously, yes, if you're running, if you have two MySQL servers, like one running on some old hardware with spindles, one running on SSD, the cost of accessing I/O would be completely different, right? So you can tweak those tables to reflect that. And of course, you can always revert your changes. Yes, so you can just update the cost value to null, and you will start using defaults again. So once you make some changes, make sure that you run flash optimizer costs query to force optimizer to reload those cost tables and to start applying them. If you're doing some sort of tuning, like you're interested in how queries compare in terms of the cost, after a query execution, you can run show status like last query cost, which will just show you some sort of number, which will be basically the cost of the last query that you executed. So it is pretty helpful when it comes to comparing different queries. So we have index statistics, we have cost model, so we are able to figure out some sort of, the optimizer is able to figure out the most efficient query execution plan. At least that's what it is thinking. And the thing is that sometimes those most optimal execution plans are not really the most optimal. And sometimes, again, with every version, optimizer is getting better with it. But still, it may happen that some query execution plan will require a human touch. And that's where the index hints come in. And they allow us basically to enforce some changes in a query execution plan on the optimizer. So first of all, we have index hints. So these are 3 of them, like use index, force index, ignore index. So use index, force index are virtually the same, with an exception that for use index, full table scan is a valid option to pick from. For the force index, full table scan is marked as extremely expensive. Therefore, it won't be used as long as it is possible to use the index that we are forcing. And ignore index, basically, it just tells the optimizer not to use a particular index that we, for some reason, don't like to be used. And here we have the examples of how you can use it in practice. So on the top left side, top left, we have a force index. So we are just forcing index IDX FK customer ID on our query. And indeed, optimizer used this index. You can see it in the key column here. On the top right, we are strongly suggesting that optimizer should use this index as long as it will be better than full table scan. And again, optimizer obliged. So the key chosen is the index that we wanted. On the bottom, then we are ignoring this index. Yes. So we're ignoring index IDX FK customer ID, and again, the key chosen was rental days. So if you take a look at this query, basically 2 options are possible. 2 indexes are possible. So we can use the index on the rental date, or we can use the index on the customer ID. And on the bottom, we ignored the index on the customer ID. Therefore, optimizer had to use the index on the rental date. And also, one of the proofs that it's not just some sort of accident that this is how MySQL executes this query, is the fact that without those force index or use index, we would have two keys here, because we can use either key on the customer ID or on the rental date. But right now, only key that is that is considered by the optimizer is the key on the customer ID, the one that we forced or that we suggest that it should be used. So that's how we execute them. Hints can be located in different places, so you can use them like globally. Yes, we can use them on the we can use them basically also for join, like on the per join basis. We can use them also for order by or for the group by. So there are a couple of basically methods, locations where you can do that. Yes. So basically, it's the options available are for join, for order by, for group by, and if we use the force index, like the global force index, we are somewhat aggregating all of those options in total. So another way, maybe it's not the index hint, but it's also related. It's also like related to that. Is the straight join. So basically, when you're executing a query with joins, inner joins, MySQL Optimizer has to decide in which order those tables should be joined. And again, result is not always optimal. So we may want to manipulate this. And this is where straight join comes in, and it allows us to basically force the order in which tables will be joined. Yes. It works for join only, because left or right joins, they are already enforcing the order. But for the join, it is pretty useful, I would say. So let's assume a query like this. So we are selecting actor ID and title from film actor, join film on film actor film ID equal to film ID, and we are ordering by film actor ID. And here we have the explain of this query. So as you can see, Optimizer decided that it will start with the table alias as f, which is a film, and then it will join the table alias as fa, which is film actor. And this is actually the first. This is actually, as you can see, Optimizer decided to revert the join order, because we're writing the query like from film actor join film, while in fact it's executed as from film join film actor. And this is basically, it may be, for some reason, Optimizer decided it is better to like that. So what happens is that we are using index on the title, which also covers actor ID, because this is the primary key, and with InnoDB, primary key is like added to every secondary index. And we're basically doing index lookup, and we're also doing some sort of covering index here. So, but then we have this using temporary using file sort, because we are ordering by film actor ID, and obviously it is not possible to. This is the second table in the join order, so we cannot do anything like that. To make sure to use some index for the order by. But let's assume that for some reason we want to avoid temporary table, and we want to use the index for the order by. Yes. And following query will help here. So we need to revert the order. Yes. So we just put the straight join at the beginning of the query. So we're running select straight join, actor ID title from film actor join film. Yes, and then we will be forcing the order film actor join film. And let's take a look at it. So as you can see, indeed it happened like we expected. So we have the film actor table, and then we are joining film table. So as I said, as we wanted. And right now we can use the primary key on the film actor ID, and we get rid of the temporary table here. Yes, and file sort, because we are using it to handle the order by for us. So thanks to the straight join, we're able to get rid of the temporary table. So you can also manipulate the join order within the query. So there are like two options. Like you can put the straight join in front of the query, like we did in our example. So for example, here, like we have select straight join table 1, join table 2, join table 3. Yes. So we're enforcing the order table 1, table 2, table 3. But if we are interested only, for example, in table 2 and table 3 order, we can write query like that. Select from table 1, join table 2, straight join table 3. So right now we have more, optimizer has more options to pick from. Yes. So because first of all, definitely table 3 will have to be joined to table 2. But the question is where to put table 1. So it can either be table 1, table 2, table 3, or it can be table 2, table 3, and then table 1. It is better to give more flexibility to the optimizer because the query executions plan may change, and as long as we are okay with like enforcing some subset of some part of the query execution plan and not the rest, this could be really this is personally, I think this is the best idea, because then optimizer can work with some other elements and can change them should some, for example, data distribution changes or new data is being added to the table. So that's personally, I think, is the way to go. So we had the hints, right? And then also we have some way to control the optimizer itself. Yes. So it's called optimizer switch. The thing is that in time, every new MySQL version gets some improvements, and new optimizer gets smarter, and new algorithms, new optimizations are being added to the optimizer. And it may happen that when you perform some sort of upgrade, yes, to the newer MySQL version, this new feature impacts your old query execution plans. It changes them, and changes them in a way that you don't like. So luckily there is a way through the optimizer switch variable to disable or disable some of those optimizations that were added. And you can see the select add optimizer switch. That's basically how it looked like for the 5.7. If you're running MariaDB, you will see some more optimization, some more algorithms added here, because MariaDB also, they had a very nice optimizer team, and they also were doing some additional work on the optimizer. So they have some more stuff here. And then you can basically manipulate this variable either on the global level, just set global optimizer switch equal to, and then in quote optimization name and equal to off, for example, to disable it. You can also set it on the session level, which makes possible to run it on per query basis. Yes, so you can set. I mean, on the session level, you can disable some sort of optimization, execute a query, and then, for example, enable it again. So it's getting more granular, which is something we like. And basically, sometimes that's the only way to to make sure that the query will be executed, in an optimal way. For example, after the upgrade. Okay, so the next section will be covering some optimizer hints that were added in MySQL 5.7. But before we proceed with that, I will hand over to JJ for our next poll.
Yeah, thanks, Christoph. Yeah, so we'll take a quick break just to ask all of you in the audience another question, and that's around which performance monitoring tools for MySQL you currently use. Since we're looking at some of that information here as well during this webinar, so it'd be great to get your feedback here. Whether you use Grafana, Cactile, or PMM, or maybe Oracle or Monarch from WebYog. Some cloud-based monitoring, maybe you use cluster control, or maybe you don't use any the database-specific performance monitoring. So it'd be great to get your feedback here. I'll just let this run for a few seconds, and then I'll share the results, of course, with everyone. And just a reminder also that you can ask questions about today's content at any moment during the webinar by using the question section of your control panel. So feel free to submit your questions there, and we'll take some time at the end of the webinar to answer them. But for now, thanks for your feedback here. I'm just going to close this now and share the results. Thank you. So it looks like most of you don't use any database-specific performance monitoring so far. Maybe it's a choice as well. That's interesting to see. And then nice to see cluster control users, and then a mix of open source tools such as Grafana, Cacti, or PMM. So thank you for your feedback here. Christoph, any comments on this before you take back? Christoph?
Sorry. Okay, can you hear me now?
Yeah, we can hear you now.
All right. So as I said, definitely there is many tools out there, so people can pick whatever they like from that. And well, the only thing I can suggest is to pick like be it cluster control, Vivid Cortex, or Cacti, Grafana, PMM, whatever. Just make sure that you have a visibility into your systems. So for those 47%, I would strongly recommend to take a look at different possible solutions and pick one of them, because it will come really handy when things will go really bad and you need some sort of visibility into your databases.
Great. Thanks, Christoph. I'll hide this now and hand back over to you.
Okay. Thanks. Thank you, JJ. So as I said, we will be talking about optimizer hints which were introduced in MySQL 5.7. So the new way of controlling optimizer has been added in 5.7, and those hints they use comment-like syntax. So basically, it's a comment and with a plus at the beginning. What is important is that those hints, they take precedence over optimizer switch. So you can have some algorithm disabled using optimizer switch, but you can enable them via this command, via this hint. Also, the other way, you can have enabled some sort of optimizer algorithm using optimizer switch, and then you can disable it here on a per query basis. What is also very good is that they work on multiple levels, and they are much more granular than the optimizer switch. So we have they work on some of them work on the global level, some of the query block, like per query or per subquery, but also they can work on the table or even on the index level. So as I said, it is very useful to have us very additional control over how you're going to execute those your queries. And these are the hints available as per MySQL 5.7. So we can control batch key access, we can control block nested loop, we can control, and this is a pretty interesting one, we can control the max execution time of a particular query. I will talk a little bit about later. We can control multi-range reads, we can control index condition pushdown, range optimization, semi-join, we can control how the materialization will be performed. So we are talking about majority of the most popular, I would say, algorithm. And we can just work on them on the different scopes. Yes, on the query block scope, table index. So very high granularity to some of them. They can be used. The hints can be used at the beginning of the statement. So basically, you run select and then the hint, update and then the hint. They can be used also in subqueries. So, for example, like in this example, we have select union select, right? So the hint is affecting only this particular select part of the union. Also, classic example of in-close, subquery in in-close. Yes, so we update something where x in, and we have a subquery here which can be modified using the index hint, optimizer hint. It also, of course, can be select where something in subquery. So, and also insert into table, select from some other place. Yes, so subqueries can be edited, like manipulated using those hints. Can be used also on a table level. So, for example, here we can see that we are joining three tables, T1, T2, T3, and we disabled batch key access on first two of them. Yes. Optimizer hints can be also like grouped together. Yes. So in this particular case, we have again join T1, T2, T3. So we are disabling block nested loop for the whole query, and we're enabling batch key access for a table 1. The hints can be used on an index level also, right? So so we can either enable multi-range read on every index in the T1 table, or you can, for example, disable range optimization on indexes in a T3 table. So as I said, it is really granular, and it is really nice way of having control over the precisely how the query is going to be executed, which is obviously useful in some cases when, like the edge case, when you just struggle with particular query. Those hints can help you to create an optimal execution plan. As I said, the max execution time is pretty interesting. It applies to the whole select and applies only to like read-only selects. So selects cannot invoke storage routine, nor select is within a storage routine. So for those, it won't work. So basically, as a DBA, for me, this is a very handy way of adding some sort of safety feature. Like in case of, like, I'm not sure how long the query will take, right? I'm working with optimizing some queries, and I'm rewriting it somewhere, and I'm not entirely sure how long will it take, because it might be good, the query execution plan might be good, but it may be even worse than what we have right now. So I can just use it to limit the maximum execution time, and it's in milliseconds. So the max execution time and 1000 is basically the query can be executed only for 1 second. So I can set it like 30 seconds, a minute, whatever I feel is suitable for this particular host, for this particular workload. So it is very, I would say, very nice way of nice addition to the DBA arsenal. Okay, so let's think a little bit, summarize some pros and cons of using index hints. Definitely, on the pro side is that hints enable you to fix mistakes, misoptimizations of the optimizer. So if something goes wrong, you can just change it. This is great. Sometimes it's the fastest way of solving the problem, yes, especially if you have some sort of direct access to the query. So you can just modify the query for some index or do some hint or whatever, and yeah, it runs smoothly. Because, for example, sometimes the alternative would be to create some index maybe, and if table is large, then the index creation will take long time. It's annoying, and so it's very fast way to influence the queries. And also for the upgrade, it's also some sort of the ability to disable some functionalities of the optimizer is really great, because you can solve upgrade problems using just one optimizer switch. Very, very handy. But there are also some cons, right? So hard-coded hints can become a problem, because let's say I'm forcing an index, and then I remove this index. You will end up with key name does not exist in a table, and of course the query will break. It will not execute. So not very funny, and not a nice place to be in. Yes, so you have to take additional attention. You have to pay attention. You have to take care of all those indexes that are added, they are forced, or they're ignored, and this could become a problem. Yes, one number of optimizations of hints will grow. So when you upgrade to the next major MySQL version, every query that is, the hint syntax is something which should be on your list to check regarding the compatibility, because this can change, right? And especially now when we see new hint syntax added in 5.7, it could be that at some point, like not in 8.0, but maybe in next or the sometime in the future, like 2-3 MySQL releases in the future, maybe they will decide to move, to move the index hints also to this new comment-like syntax. So things may just change, and this could be a problem, because then you have to rewrite all your queries to use the new hint syntax. And of course, last but not least, the thing is that when you force the query execution plan, you have to keep in mind that there is no such thing as optimal query execution plan. Like totally optimal. It may be optimal in time at this point, but this will change. New data will be added, some data will be removed. and query execution plan may be completely different. The optimal query execution plan may be different in the future. So forcing is not always the best idea. Okay, so let's take a look at the optimizing of the SQL. As I said, I'm going to show you a couple of anti-patterns that I found. I mean that I've seen while working with different customers. And let's take a look at what we can do about them. So first of all, we need to keep in mind that MySQL is getting better in executing queries every single release. And you will see some examples of that here in the next couple of slides. First of all, subqueries. Yes, so they used to be a really pain point in MySQL. People were just making fun of MySQL that it's not able to execute subquery properly. It has changed. So here we have classic subquery in close. On the left side we have MySQL 5.5. On the right side we have 5.6, 5.7. So first of all, let's take a look at the query. So what we do, we select a star from film where film ID in, select film ID from film actor where actor ID equal to 1. Seems pretty easy. Yes, so we just execute the subquery. We get the film ID where from the row where actor ID equal to 1, and then we just use it in the outer query. Sounds pretty efficient. We can use index on actor ID here, and then we can use index on the film ID here. Well, not so optimal in MySQL 5.5, as you can see. We basically ended up with a table scan on the film table, and the subquery was marked as dependent, even though it's not dependent at all, because it can be just executed, evaluated, and then it's used as a constant. So obviously not so optimal query execution plan. 5.6, it has been improved. As you can see right now, the query execution plan looked like as we thought it will look like. Yes. So we're using on the film actor, we're using the primary key to find the actor ID, and then on the film table we're using the index on, again, also the primary key to find the row based on the film ID. So this is what it should look like. The pretty common way of solving this problem for MySQL 5.5 and earlier is to rewrite subquery into join form. So we can basically execute it like select from film, join film actor using film ID, where actor ID equal to 1. And as you can see, we managed to get the correct execution plan. That was the same like we had in the 5.6 or 5.7. So we're using primary key for film actor and primary key for film. So that's what we wanted. And this is a pretty common way of solving the subquery issues if you're running older MySQL versions. Joins. So joins are nice, joins are flexible, but when you're working with joins, just make sure that you're indexing them properly, because it's really, there's not, it's just crazy to see, unindexed joins which are, slow, cumbersome, and just, can be speed up just by adding some indexes here and there. So let's take a look first on the right side. So we have basically join of 3 tables. Each of them is like 10,000 rows, and as you can see, we have a full table scan across the board. And on the left side below is the output information, the output of the show status like handler, with the information how this particular query was executed, what kind of access it did. So in short, in total, it executed 160,000 rows and performed the table scan. Yeah, so it read 160,000 rows. for 3 tables, 10,000 rows each. So pretty annoying. And you can imagine what would happen if we had not just 10,000 rows, but let's say 1 million rows per table. That would be just crazy. When we add indexes, things are slightly different. So we can, the index are being used correctly. And you can see in the handlers that we executed 20,000 rows were examined instead of 160,000. And actually, when you see this, or what you see here on the left side, is pretty nice way of profiling a query. So what you do is you just flush status. It flashes some of the status counters per session level. You execute your query, and then you just show status like handler. You will see basically what type of row accesses the query you just executed did. So pretty convenient way to see why the query is slow, or what maybe can be done else to improve it. Another problem, pagination. So it's pretty common to use limit for that. Yes. So I want to show 10 results per page. So we just run query and then limit offset, 10. And thing is that you may think that it will scan 10 rows, but if you use like limit 9,000, 10, it won't scan 10 rows. It will scan 9,010 rows, and then discard the first 9,000, which is hardly efficient if you ask me. So again, and here's the proof, right? I'm doing the same trick. I'm flashing status, running query, and then showing show status like handler. And indeed, as you can see, handler read random next, which is the full table scan. As you can see, we just scanned like 9,010 rows. A solution for that would be, for example, to basically not use limit, use some ranges. Like let's say ranges on the primary key. Yes, you start from 1. Let's say it's auto increment integer. So let's start from 1 and then just get the range until like let's say 200. Check in your application if you get at least 10 rows. If you got 10 rows, then just find the row, the last row, last of them. Check its primary key value and then use it as the beginning of the next range. If you didn't get 10 rows for some reason, increase the range until you get them. It will be much more efficient than using limits, especially after some time, because limit at the beginning it is okay, but when you go like that, when you go to thousands, to the offsets of thousands, this become more and more problematic. When you're using union in your query, make sure that you use union all, because unless you really need to have a distinct values, because the union all enforces a distinct clause, and it results in a temporary table with some index created. Union all also requires temporary table up to 5.7, but at least there's no index created, so it is like lightweight type of temporary table. So it is much, unless you really need distinct results, you should use union all, or even better, union all and then aggregate and remove remove duplicates on the application side. And here we have another example of it's the of the improvement in MySQL. So as you can see on the left side, we just run some query and then union all some other query. As you can see, we have three tables. First table, second table, and then we have union result with using temporary. In 5.7, we don't have a temporary table here anymore, so we just have two tables joined, unioned, and that's about it. So this was improved in MySQL 5.7. For group by and order by. So first of all, just make sure that index is used. Yes. So because otherwise a temporary table will be created and file sort will have to be performed. So again, on the left side, we can see that we used the key primary key for the order by. So we just do index scan and that's it. Yes. On the right side, we are ignoring primary key. So MySQL cannot use, the optimizer cannot use primary key for for sorting. And then, well, we just end up with table scan and we're using file sort. So as long as it is possible, make sure that you sort or aggregate using index. So if you're using in a join, if you're aggregating in a join or sorting in a join, try to aggregate using columns from a single table only, and this table should be the first one in order, because these are the conditions under which MySQL can use indexes for the group by or for the order by. Because MySQL cannot use multiple indexes except from the same table, except through index merge, which is something I will be talking in the next slide or two. But there's no way to use index across multiple tables, so you cannot just use, for example, index from table 1 to order by and table 2 to group by. It's not possible. Both order by and group by will have to be through the columns which are on the one single table. And the index merge. So I have a problem with index merge. There's no problem. It is an optimization, definitely. But I really have mixed feelings here. Definitely mixed feelings. So first of all, let's say on the left side, we have select from table. We're ignoring composite index on the B and C columns, where B something and C something. And we have indexes on B and C. So it's a perfect candidate for index merge. And as you can see, indeed, MySQL used index merge and intersecting both indexes on C and B to evaluate the rows. On the right side, we have a composite index. So we just stopped ignoring this one. And it was used to index on the B and C. So at the bottom, there's a query from a performance schema which tells us about the duration of those queries. So the query which used index merge takes 0.012 seconds. The query using composite index 0.003. So basically, and that's my problem with index merge, is the fact that the composite index is like numbers of magnitude, in this case, two orders of magnitude faster than index merge. And if you can do some index merge, like 99% of the time, you can use composite index to speed things up. So that's obviously it's better to have index merge than to use just one single index. But if you can use index merge, you should be adding. You should just create a composite index on those two columns. Order by round. So avoid order by round. I think that's a pretty popular I mean, it's pretty common anti-pattern, and you are familiar with it. Basically, order by round will create a temporary table, always. And it is bad. Order by round is really bad. We don't like order by round. Instead of using order by round, just outsource it to the application. So for example, if you want to get just single random row, collect minimum and maximum primary key range, just generate value, assuming that you are using integer, auto-incremented integer primary key, and you kind of should be using like that. Just order, generate some random value and execute it, like where primary key equal to this random value. If you get the row, you have your random row. If you didn't get the row, right, execute the query once more, or use inclose. Yes, and it's also if you want to, let's say, get like 10 random rows. Again, take minimum primary key, maximum on the primary key. Within this values, generate, let's say, like 100 or 50, maybe, like whatever, random numbers, and then use those 50 random numbers in the inclose. If you feel like, if you want to get 10 rows, just run those, use those 50 values, see if you can get 10 rows out of it. If you got, that's fine. If you didn't, generate next 50 rows and just repeat until you get the needed 10 rows. Both type of accesses are primary key lookups, either the primary key equal to something or primary key in some list of some values. That's a primary key lookup. That's fast and efficient. And basically, this type of approach will just do cycles around the order by round. So there's no point in trying to use sort and find random rows using order by round. Regarding query parallelization, so the MySQL has a limitation that the single query is a single thread, which means single query, can use only a single core of the CPU. So, and while there are some sort of workloads logs which are pointing to this, there's some work on that. Right now we are here, and right now we cannot use multiple cores per query. But we can, under some circumstances, we can go around that. First of all, let's say that you have a partitioned table, yes, and let's say you store data from, let's say, on per monthly basis, yes, partitions per month, and then you want to get data from, let's say, last year, maybe 12 months, yes. So normally you just run a SQL query, but in fact you can execute some queries on per month basis, and then aggregate the results in your application. So instead of one query, you can run 12. It's just a matter of scripting it. Or you can use shard query tool from Justin Swanhart, which is basically intended to help to parallelize workload on the MySQL system, MySQL database. Not every query will be suitable for parallelization, but if you can do that, you do it, because most likely you will see a huge improvement in terms of the query execution time. So that's mostly it from myself. If, as I said at the beginning, if you haven't watched our previous webinars from this trilogy, you can check out our webinar replay page. Feel free also to register for upcoming webinars that we may have, that we will hold in the future. And yeah, if you're interested in classical control, then just get started with it following this link. And that's it from me. And before we go to check some questions, I will hand over to JJ for the last poll of the day.
Yeah, thanks a lot, Christoph. Thanks for the presentation. And if there are any questions, there's a couple of questions there already. If you have questions for Christoph, feel free to ask them now using the question section of your control panel. And in the meantime, I just wanted to ask all of you one final question. And this is just to see whether you use index or optimizer hints in your queries yourselves at present. And this could be there might be a couple of different answers here, but between index hints, optimizer switches, maybe optimizer hints in MySQL 5.7, or maybe you don't use them. It'd be great to get your feedback here. I'll let this run for a few seconds, of course, as usual, and I'll share the results as soon as most of you participated. And just as a reminder, you can ask us questions by using the question section of your control panel. So feel free to use that. We still have a couple of minutes we can use to answer questions. But for now, thanks for your participation here. I'm just going to close the poll and share the results. So it looks like the vast majority of you don't use them at the moment, but you see value in it, and hopefully you got some good insight as to why they're useful, or what the value might be, and how to use them, how to apply them. Christoph, any comments on this before we look at some questions?
Yeah, I mean, I think, well, I kind of agree what you just said. I also hope that you found some. I mean, even if you're not using them, you find some value. As I said in the webinar, it is. I mean, it's recommended not to like overdo. So just not hand control every single query out there. But in some cases, it's really helpful. It is really useful to have this, to have those options at hand and try to manipulate your queries if needed. And well, it's also nice to see that people that are already using hint syntax from 5.7. So very, very nice to see.
Great, thanks, Christoph, and thanks everyone for participating in this last poll. Let's just we still have a couple of minutes, so we can maybe answer a question or two. There's a question here, Christoph, on whether you have any suggestions for optimizer settings when using a star schema layout.
Yeah, the thing is that, I mean, I'm afraid there's no such thing as default settings for a particular way of using the database. To really help, you just have to see the queries. You just have to see what type of query execution plan you're getting, why they are incorrect, and then you can just try to work out and find some solution for the problem, because there are so many reasons why you might get incorrect execution plans. It could be just a data distribution. It could be index statistics which are recalculated too often. The queries plans are just flopping. It's really hard to tell without just looking at the system and actually understanding what is the problem. So no, there's no such thing as generic suggestions that could be applied here, unfortunately.
Okay. Okay, thanks, Christoph. And if there's any follow-up questions, feel free to send them to me directly if you like, jj@severalnines.com, and we'll make sure to answer your questions there or continue the conversation there. And just a reminder, of course, that today's webinar was recorded, and we'll make the recording available tomorrow probably. So look out for a blog on this, and we also have our newsletter every Thursday where we communicate the links to our replays and also to upcoming webinars and so on. So there'll be an email about the replay details there as well. And we're just at a quarter past now, so we're just on time finishing the webinar. Thanks a lot, Christoph, for today's presentation. And thanks to all of you for participating today. It was good to have you with us. Again, you can install Classical Control here from our Getting Started page. You can sign up for our upcoming webinars, and always check out our blog as well, where we post on a daily basis about topics related to today and also other topics, of course. But for now, I think we're finished for today. Again, thanks for joining us. Look out for the replay information, and we'll have invitation emails soon as well for upcoming webinars. So thank you very much. Have a good rest of the day and a good week, and we'll talk to you soon. Thanks and take care. Bye-bye.